My name's Duncan McFarlane. I run something called the Distributed Information and Automation Lab here at the Institute for Manufacturing in Cambridge. And what we really do is look at industrial applications of emerging automation and information technologies. And this talk is a reasonably elementary introduction to industrial Internet of Things, but also Internet of Things generally. And I'm just going to really attempt to touch on some basic questions, and because it's lunchtime, I thought I'd take a light-hearted approach, and so most of it you'll see is in terms of cartoons. So you'll have to judge the artistic quality of those yourselves, but best I could do. So I'm going to move us on to the next slide. At least I thought I was. Maybe I'll do a different thing. We've got a bit of new technology going here. Thank you. The internet. What I'm going to do is break this talk into two parts. Firstly, I'm just going to spend the first 15-20 minutes just talking about the Internet of Things, and I'm sure almost everybody online has actually heard of the Internet of Things. I'm less sure how many actually know what it is and where the idea came from and what it was intended for. So I'm just going to, before we talk about the industrial use of Internet of Things, I thought it'd be useful to spend the first half really discussing the Internet of Things. And in some ways I'm in a good position to be able to do that because I was involved in the very early days of the notion of Internet of Things. So you'll see as we go on, I don't want to spoil the excitement. So then the second half will be about industrial applications. So Internet of Things, what is it? This is the most boring slide of the webinar. So it's essentially it's the ability to network physical devices, equipment, vehicles, any other item, and by embedding it with electronics and software and getting it, achieving a network connectivity for those items, so we can actually gather information about objects and exchange data about those objects. So the thing bit is important to remember, because at times we lose the thing bit in our thinking about IoT, but that's the origins. It's about connecting things to the internet, as it sounds. So yeah, the first graphic there is a very simple attempt to illustrate the basic mechanisms of the Internet of Things. And I kind of going to talk about three parts. Down the very bottom, we've got collections of sensors and actuators. So sensors that gather information, actuators that do things. And the idea of the Internet of Things is that we can gather information from those items or get information to those items from some form of what we call a gateway. This is the language I'll use most of the time today. There's those boxes superbly coloured in green, yellow, and red, and those gateways will then gather data and pass that information predominantly to the cloud, to some sort of server location, but generally we're talking about cloud-based servers. So they're the three basic elements of Internet of Things. So one of the things I'm asked quite often is, can you tell me about the origins of the Internet of Things? And the next slide is very close to really what the actual origin of the Internet of Things was. And this is a picture that came from a project I was involved in, Cambridge and MIT and other universities were involved in back in the early 2000s, called the Auto ID Centre. And what you see there is a rather poorly drawn bowl of pasta talking to a microwave oven. And this notion of a physical object being able to talk to a machine or a device was the driving point for this project, the Auto ID Centre, which was actually looking at next generation barcodes. So in fact, looking at using RFID as a means of connecting an object like a bowl of pasta to the internet, and using a radio frequency tag attached to the object and an identifier on that tag to point to where data might be held about bowls of pasta. And therefore the microwave also connected to the internet ought to be able to interrogate that information. So back in actually it was 1999, Kevin Ashton, who was seconded from Procter & Gamble to work on the project, actually coined the phrase Internet of Things for the first time. And the thing that came from that idea, which is something we worked on for the years following, was the notion of what we call an intelligent product. And the intelligent product is, if we've got this bowl of spaghetti connected to the internet, could we actually, to a certain extent, give it a way of thinking about its own progress? And clearly, it's very hard to put a brain or even a computer inside a bowl of spaghetti. But if you connect that to the internet, then perhaps you can put some thinking about on behalf of the bowl of pasta onto the network. So we came with this idea of an intelligent product, which if the bowl of pasta had the notion of how do I get myself cooked, then we identified that it needed 5 things. It needed a notion of identity, just like a person does. In fact, all these are like a person. It needed the ability to sense its own state and a communication mechanism to pass on that state to the network. It needed to be able to manage data about itself. Then they're more complicated. It needed a language in which it could actually not only send messages, but actually send meaningful messages, for example, to the microwave oven, and ultimately support decisions, so have rules and mechanisms available. So this was the idea of an intelligent product, and to a certain extent, the vision for our vision for Internet of Things is based around that. So I'm going to leave that vision for the moment and start to now pick up the next question, which is what's the internet bit of this? And so if you look at this slide, those of you that are old enough, and I'm just about old enough, will remember that the internet actually began life in the US military in the 60s as a means of connecting disparate computers together. It then evolved over the next 20 to 30 years as more and more computers and requiring more and more sophisticated networks in order to connect not just a couple of computers but large numbers. And to the extent where we in the 90s, most people around the world were, for example, using email using internet. Then in the 1990s, we started to consider the expansion of internet capabilities to start to consider other devices that might be connected, and tablets, mobile phones, PDAs, personal data assistants, which don't exist on their own anymore, but we're very excited about back in the 1990s, were all devices that could be given network connections in the same way that computers could have a network connection. And then moving on, and these dates are rough. In fact, almost everything in this talk is rough, but you get the idea. In the 2000s, we became more and more interested in how we could get machines and equipment. If you're struggling with the images, that's a car, a robot, and a fridge there. But so devices that were powered, but ordinarily not necessarily connected to computer networks. So we looked at mechanisms whether by embedding in computer capabilities onto those devices, or at least in having reasonably sophisticated communications, we could also give those items IP addresses and have them as part of the internet family, if you like. And then this latest stage is where we've moved to things. So whether it be a car tire, a chair, a suitcase, or a piece of cargo, mechanisms for getting objects, everyday objects, which may or may not have any powering computer capability, but by the use of technologies such as radio frequency identification, wireless sensor nodes, Bluetooth tagging, etc., we can come up with mechanisms for connecting also those inanimate objects to the network. And that's really where the notion of the Internet of Things comes from. It's more or less an extension of the internet to expand to take into everyday objects. And the one comment to make there is that obviously none of those objects have themselves connected to the internet, so they normally are going to be through a third-party device, such as an RFID reader you see on the right-hand side. Let me point to that there, RFID reader, or through a Bluetooth reader, etc. Or, for example, a car tyre talking through the local communication system on a vehicle. Okay, so that's the backdrop. The backdrop to where the Internet of Things and the Internet come together. They really are part of the same thing. The Internet of Things is ultimately just another step in the extension of the Internet. So two reasonably technical, well, as technical as we get today, two technical issues. Firstly, what is the Internet, and what is the Internet of Things, and what isn't the Internet of Things? So first down the left-hand side in blue, these are the points I would make, and maybe worth remembering in terms of what Internet of Things is. It is an enabling infrastructure for connecting objects and things and entities to the network. It's also, therefore, because we can connect them to the internet, we can therefore connect them to each other using the internet as a medium for doing that. It is an extension to the internet, and it enables sensing, which is where a lot of the focus has been so far, but also decisions and actions to be made involving everyday objects. By contrast, the right-hand side then says what Internet of Things isn't. It's not a new application or a new service, although it might be the enabling infrastructure for new applications and services. Importantly, as it stands today, it's not a new separate network of objects. The objects are actually being joined to an existing network. And that's important, because often we don't just want to connect an object to another object, we want to connect it to a machine or a computer or a device. So it's actually massively beneficial that it's part of the same network. It's also not just about getting sensed information from objects. Actually, there's very limited value and benefit in just gathering sense data on its own. What we really need to be able to do is to analyze data and make decisions about that object or other entities, and then put in place actions that benefit from that informed decision. Equally, it's not about big data, or it's not just about data analysis. There's a potential for some significant data analysis to be performed, but often these two things are used interchangeably, and they're clearly, there's quite different emphasis. And it's not also about database coordination. Where having said that, we require databases and data management, but as we'll come to in a moment, that's just part of the picture. So an Internet of Things is not a technology as such either. It just enables enabling lots of new technologies. And one way to think about the types of technologies it's enabling is the next couple of slides. So I've entitled this "What Happens on the Ground," and what I mean by that is, if you look on the left-hand side of the slide, we've got information coming off an object that's being sensed, transmitted, received at a base station or a gateway, and then being put onto a network. And that's the sensing part. And the actuation part, or the acting part, is from the network, transmitted, and through a gateway, transmitting information to a node, and where that's received and an action's taken. So how do we, there are a lot of mechanisms, a lot of ways in which that type of process can take place, not just one approach, and there's a whole range. And this rather hastily drawn sketch tries to pick up some of the different mechanisms that are being used, at least in the wireless space. And I should emphasize, Internet of Things is not just about wireless either, but a lot of the developments you hear about are wireless. And so, the developments range from let's go to the far right-hand side from what we call low-powered wide area networks, where sense data has been gathered over up to 15 kilometres and being transmitted infrequently at very low powers to a base gateway. To the other extreme at the low bandwidth end are the body area networks, where people are developing ways in which you can have a network based around the clothing you're wearing or the sensors embedded in your body. I hope you don't have too many of those at the moment. And then at the other extreme, and perhaps into the space where a lot more of the industrial stuff operates, we move up through RFID and Bluetooth, where we're getting more bandwidth and therefore being able to move greater data volumes at data rates. And to use of Wi-Fi and the evolving 2G, 3G, 4G telecommunications communication mechanisms. So range and data volumes is just one way of looking at this. But it's important to look at it because, for example, the Zigbee, which is a lot of home wireless sensor networks have been developed around, is just as much an Internet of Things development as RFID or Wi-Fi or low-powered wide area network. So no one of them has an exclusive hold on IoT. So that's what happens on the ground. And I guess the next bit that goes on is what happens in the cloud. So once that data has been gathered, there are numerous organizations providing cloud support for that data. And again, we hear a lot about data analytics going on with data that's been gathered from sensed information associated with objects. But the reality is that the jigsaw is quite a bit bigger than that, and I've only just picked up 6 of the pieces here. But from a very for example, we need to be able to link the data that's gathered with the object that the data's come from, and perhaps other similar objects. And for that, we need to be able to catalogue classes of objects and be able to search for them and where they're being used. Going down, then we need to be able to gather queries. So, because if this is going to be, if this data collection is going to be useful, then it should be able to respond to queries being made. And we are looking to analyse data and to discover trends, predict future behaviours, etc. And then down the bottom, reporting is clearly critical, but equally critical on the bottom right-hand corner, actually being able to gather rules associated with the information that's being gathered, and they're executing controlling commands that will go back down to actuators that are connected to the sensed information. So this and more are the sorts of things you could expect to happen in the cloud associated with an Internet of Things infrastructure. So when is IoT useful? Well, that's an interesting question, and a question I was asking a couple of years ago was, is IoT useful at all? And having looked into it quite a lot more since, I think you can start to categorise situations when just your standard sensing infrastructure that may be in place in a building or in a home or in a factory may not be sufficient for the type of needs that are required. And so down the left-hand side there, I picked out just some of the categories which might be boxes you'd want to tick if you were thinking about, should I make an investment in getting involved in Internet of Things? So if there's an application that requires data to be gathered from multiple organisations, then sometimes actually having a mechanism which gathers information from beyond the business information system environment of an individual organisations is very attractive. So it doesn't get you over the security challenges, but it maybe unifies the security challenges for that application. Secondly, if the system is naturally distributed, then that can certainly lead to some advantages in considering a system of the sort we're talking about. And the little diagram that in the picture on the right there just illustrates some work that we've been doing looking at distributed management of devices and objects in the home, and connecting that up through IoT environments to maintenance services, and also allowing individuals that work in the home or use the home or visit the home to make comments and add information to that asset management environment. Also, when the software is perhaps naturally cloud-based, then there's a neat link to making use of Internet of Things. So I think they're the three main characteristics, but I put a fourth one down the bottom, and this is something we'll talk a little bit about in the industrial piece, is where the application involves some degree of customization or personalization of a product or an order, then actually being able to really accurately manage the sensitive information about that object might be important. So just going to move where is IoT being used at the moment? Well, I think the area that gets a lot of publicity is around cities, and clearly cities are a good candidate because they tick all the boxes on that previous slide. So the little picture there just talks about some of the ways in which IoT is being used to manage traffic, in-city logistics, railway systems, etc. So just there and even traffic lights, and so cities naturally don't necessarily have a centralized information management infrastructure. So a distributed information infrastructure like IoT is very helpful. In fact, it could be even more helpful if we could add some smart AI-based feedback to go with it, which, if I've detected I've got some problems with traffic flows, being able to advise drivers to take alternative routes, or if I've got a logistics challenge, being able to find an alternative logistics mode, that sort of thing. Okay, so just to summarize the current IoT developments before we talk about industrial applications, there is a lot of effort going into what I call the low power long distance. So the LPWAN item I had on the earlier diagram, because and with an attempt to build some infrastructure that can be can get a kind of a network coverage for things in place. But there's also quite a lot of work going on in the background on the cloud-based issues, for example, around cataloging and search mechanisms. And they're equally important. They probably don't quite get the publicity they deserve. And the last point is that right now there's quite specific stuff going on in some focused domains. So a lot of work on smart homes, in smart cities, and we're just starting to see industrial IoT start to get some attention as well, which is interesting because actually we've been sensing things industrially for a long time, but that may be part of the challenge as well as the opportunity. So I'll move now into the second part of the talk, which is industrial IoT. So again, I'm going to just cut across the top of some of these questions, the obvious questions you might ask about industrial IoT. I think if you find I've started to answer the question, but not completely answered them, you're probably right. And I'm happy to take some questions at the end, but also just to mention we'll be running a full workshop on this issue in the new year. So what is industrial IoT? Well, let's do it really simply. We've already got a definition of IoT. So it's just the use of Internet of Things to create value, and it's important because industrially nothing really gets off the ground unless it creates value, but to create value for not just processes, industrial processes and their supply chains, but also for the products and services that are sold from the industrial environments as well. And there's an attractive aspect there because IoT gives you this mechanism not just to put sensors on processes, but on objects and products flowing through the supply chain. So a couple of diagrams to maybe set the scene. This one doesn't look remarkably different to the slide we looked at before. But in a sense, what I've done here is just literally added some industrial objects down the bottom, and also noted that actually, although we talk about cloud, there's nothing that precludes cloud being cloud is really just another way of describing a server that's located, the server capability that's located across the internet, but server capabilities locally can actually perform some of the tasks that we need to do anyway. So that's that. It really, it's a minor extension on what I was talking about earlier on. And I'm not going to spend any time talking about the way manufacturing is evolving, but I'll just put in this. Well, sorry, I've forgotten I had an extra slide here. I've just put this slide actually just picks out a vision that we developed about 5 years ago for what industrial IoT might look at. So on the left-hand side, we've got this. This is called if you can read it, it's quite small. It's called a day in the life of a blender. So on the left-hand side, we have a blender being made and having conversations with various machines in the manufacturing environment about how it's going to get made. Moving on to the right, it goes through the logistics chain, works out how to get itself delivered to a retail outlet where it's bought and sold on the right-hand side top. And maybe the retailer, based on that sale, will trigger a reorder of the blender. Then in the home, lots of excellent smoothie recipes. No, I couldn't draw kale, but kale is my daughter's favourite smoothie item for reasons I can't explain. But anyway, you get downloading smoothie recipes from the internet, potentially triggering repair processes when the motor burns out, probably from chopping too much kale, and then potentially in the recycling phase, actually the blender being able to trigger its own recycling processes. So that's kind of our vision for industrial IoT. And as I say, I wasn't going to say too much about manufacturing, but there's one piece that's worth bearing in mind when we start to talk about industrial IoT is that the image we've had traditionally of a factory being in a single organization, a single building, single location, is changing rapidly. And actually, the business of turning specifications and raw materials into final parts and products and the services that go with it is often now far more distributed. And when they're distributed, it means there's a greater interdependency than there ever has been between multiple organizations, more or less tasked with doing the same manufacturing operation. So what I'm going to now talk about is when could industrial IoT be useful? And by the way, I ought to say thank you to those people that are bringing typing in questions as we go, and we'll certainly be able. I'm going to leave them till the end, but we'll try to pick up some of them at the end of the seminar. So I just want to talk a bit about try to motivate when industrial IoT could be useful. So if this slide looks rather blank, but it's going to build up, so don't be disturbed. But what we're pretty good at today in today's manufacturing operations without IoT of any sort is gathering operational data. Now you could argue that we don't gather it in sufficient volumes for sufficient periods of time, but in terms of influencing performance, there is quite a good track record for making use of operational data. And perhaps I give that a green, whereas I give it a yellow and amber to the notion of using operational data for improving our systems. So I'm getting somewhere with this, don't worry. So if I then expanded that to include auxiliary data around the operations, so this might be information about our work in process, our quality data, operator gathered data, or machine condition monitoring data, then again, I think we make some use of that in system performance. What we don't really make great use of is that information in operational performance. So there's an opportunity to do better there. And then I expand further to the broader factory context. Again, there's lots of data available in most manufacturing operations around energy management, stores data. We've got a strange picture, but hopefully you guys aren't seeing me flashing. I'm flashing on my own screen. Anyway, I'm going to keep going. Data from people, operator data, finished goods stock availability, what the state of tools are being used in the manufacturing environment, where the raw materials are. So that sort of information, which critically affects operations is normally looked at from a scheduling context and a planning context, but actually could affect how you're operating on a daily basis. And then going further out into the supply chain, there's information out in the supply chain, for example, from the transportation systems, from the demand of sort of supplier demands for goods arriving, etc. And again, we make very little use of that in terms of our factory operations, which again we kind of assume are being decoupled from that information. And there is some information used in improving the supply chain systems. And then even going further, again, the what I would call the ecosystem information around the supply chain, the weather information, financial data about prices, traffic information, environmental information, some of which has the potential to affect the operations, and some of that could be affected by operations. But at the moment, I would give that a red, both in terms of its impact on the performance and also ability to improve the supply chain. So what I've tried to do is build up a set of data environments that aren't necessarily available to today's factory operator in terms of improving their factory operations, and therefore, if we could find a mechanism to allow us to readily introduce those additional data sources, there'd be some significant value industrially in doing that. So, and I saw someone asking the question earlier on, when is it that industrial IoT can be useful? Well, I haven't got the specific instances, but these 4 pointers are at least provide some headway answering that question. So when, for example, when there's value in integrating data from our suppliers and logistics providers and customers, because we know it can affect the way we operate on a day-to-day basis, that's one potential benefit. Secondly, if new technology or peripherals are being introduced into the manufacturing environment, or new tools and equipment on a reasonably regular basis, and it's complex to integrate that within the existing IoT environments, that's another benefit area. Or, as I said earlier, if the production is naturally distributed, so the data from one site actually could be readily used in the operational data from the other site, and finally, where information associated not with the equipment and the factory and the operations itself, but the products and the parts, where information associated with those items. So let's talk about the temperature of incoming steel billets into a steel rolling mill. That massively affects the productivity of the rolling mill. If we knew that data in real time, we're able to adjust the rolling mill, then we can take advantage of that. So the diagram on the right picks up, has 2 sets of arrows there. The left-hand arrow is saying really, is there information from our environment, from the ecosystem or the supply chain or just the area around the factory operations that could impact on the operations itself? And then the reverse question is, to what extent could the operations, the overall supply chain, be affected not just by the aggregate performance of the business data, but actually specific operational variations that occur on a day-to-day basis within the manufacturing environment. So that kind of is that tries to sum up the sort of the two-way street in terms of where IoT can provide benefits, not just in that central circle on its own, but seeing that central circle as part of a broader system, one of which we really decouple it from generally today. So the last question I'm going to talk about is how we go about, how we might think about integrating IoT with existing industrial IT systems. And I guess the point in that first slide, and apologies if this doesn't exactly look like your industrial IoT architecture, but most manufacturing organisations, industrial organisations, have pretty good systems in place for managing their industrial IT systems. So and what you're looking at there is a typical, semi-hierarchical structure which gathers information from sensors and actuators like switches, passes that through to it might be connected to programmable logic controllers or to robot controllers, drive controllers, conveyor controllers, reactor controllers, etc. And systems are then run on PCs or servers to manage the overall operations of the plant. Now, I realise that's super simplistic, and I actually have to give a student lecture tomorrow where I give that all in much more detail. But for today, I hope you forgive me for giving you a very simple view of existing industrial IT. So what do we've got that existing IT. We don't want to throw that away. So how do we think about adding Internet of Things within that environment? Well, first point to make is that actually, there are, although wireless isn't as heavily used industrially as you might imagine, because there's issues with interference and potential safety challenges there. There are capabilities that have been around for quite a while to provide wireless gateways, so that devices such as mobile devices or PCs could be actually connected in wirelessly to industrial IT environments. So they exist already, but that, if you like, that's a first step towards connecting some Internet of Things objects and devices. Secondly, increasingly organisations anyway, regardless of whether they're embracing Internet of Things, are starting to use cloud, both for performing analytics of the business data they have access to already, or actually in some cases, and it's a bit more experimental, some aspects of control where distributed operations are in place is actually being done at a high level in the cloud as well. So cloud, to me, that's the next piece in the jigsaw. Then a next step would be to consider there are IoT gateways that are being developed specifically for use within industrial environments, and their specific focus has been in integrating, for example, and these are very bad pictures, but different tools that may be different tools or storage vessels that might be used in the environment. So they're in a way, what we can then do is actually take data from those tools, could be condition monitoring information, could be usage information, and integrate that into that existing IT environment in a relatively straightforward manner. And equally, there are other devices or similar devices that enable data from pieces of equipment that are being used in operations, so the robots or the drives, to gather additional information about them, vibration information, energy usage information, and actually they can go onto the local Ethernet, the network within the factory, and so you can actually just add a little piece of Internet IoT capability to your system as a small step. And then moving on, the big picture. So yeah, and probably the picture could get bigger, but my graphic skills can't do any better than this. But if we now take that factory and put it in the small box in the centre, what I could then start to do is to make use of some of those low power wide area network capabilities to gather information from sensors that might be dotted around my supply chain or even the traffic data in the vicinity of my factory. And also make use of some of the cloud services that go with those. Some of them proprietary, some of them are open access. So that's on the left-hand side. And then on the right-hand side, potentially making use of home area networks. So IoT capabilities in the home, and that's meant to be our blender turning up again there, as well as a vacuum cleaner that might be providing information back to the manufacturer about faults that are being detected or about potential improvements that might be made. So or usage data. So what you can see is what we do. The Internet of Things picture is not quite as clean as the one I started with the cloud hanging over a whole lot of sensors and actuators. In the industrial environment, we've got a lot of sensing already. And a lot of it's wireless. Actually, a lot more of it's wired, and all of it's decent sensed information. And some of the challenges are around getting the sensed information onto the network. Actually, in quite a lot of operations, one of the challenges is getting data off our industrial operational systems into our business systems. And again, there's mechanisms being provided which can support that. So that's kind of the picture for integrating Internet of Things in industry. And I realize that's not the final answer, but anyway, that's where I'm getting to today. So just to sum things up, it's clear from the way I've described it that neither the IoT or industrial IoT are a mature field. And actually, you only have to look at the projected growth, which sometimes I don't know where the data comes from for that, but that's a different point. But it's always increasing rapidly. Secondly, industrially, in the industrial domain particularly, and I haven't talked about these at all, there are security challenges and privacy and data IP questions to be answered. And actually there are good solutions, and so not complete, but good solutions becoming in place. And also being able to understand the benefits is challenging, and hopefully at least stimulate some ideas about that. Thirdly, there's real value of being able, the potential value could be split into two bits. Well, one is being able to integrate new data streams to add value to manufacturing operations. And the other, if you like, which is it's a non-IoT thing, but being able to be better gathering existing sense data more easily and more flexibly, and potentially making use of it in different locations. So in the bottom line for industrial IoT is that, to me, it extends existing industrial IT networks, which I didn't mention, but clearly existing industrial IT networks already embrace internet capabilities as well. So it's not contradicting the earlier comment about IoT extending the internet. And there's more questions we could deal with. And as I mentioned earlier, we'll have a workshop in the new year, which we'll be able to tell you about soon, and some potential future webinars on specific issues. So an example, I was being asked only this week about how IoT and blockchain work together. And that's certainly for another discussion, but you watch the space. We may have more to say on that. So just to finish, back to our blender, and back to where I think we stand in terms of Internet of Things, and particularly industrial Internet of Things, in terms of the initial vision. So if that intelligent product, the 5-stage intelligent product definition, I would say we've got really ticked two of the 5 boxes so far. We're capable of gathering identity of objects and things. We're getting better and better at sensing and communicating the data that's gathered. The data management is coming along significantly now with a lot of cloud-based work. A language which would allow that blender to talk to the robot that's assembling it is, for example, we don't have any definitive work there, and a lot of standards work needs to be done there. But actually, the interesting thing may be IoT and AI, as I purported in the cities slide earlier on. How can we best support decisions that need to be made about an object? And that sounds a bit Star Wars-like, but actually, in some cases that we look at, the only way for an object to get things done to it is for it to look after it itself. They're very good examples, for example, in infrastructure assets where there's no other cost-effective way to do it. So I'll call an end to the seminar at that point, but we've got 5 or 10 minutes to address some questions if people would like to pass them through. Okay, well, while I'm waiting for I've just seen a comment about blockchain, which I think someone said, it's the most inefficient technology that's ever been developed. Yeah, I think I agree with you, but I'll have to wait till the next webinar, definitely. So we've just picked off some of the questions. What are the most common sensors I've seen for IoT in automobile and aerospace industries? Well, actually, so I think what I would say is the sensors in those industries are actually really well developed. So they're all, the sort of sensors that manage most of the machining operations, assembly operations are already embedded. And, you could say they're IoT because they're part of the broader family. But I think that the most common sensor I see that's being added as an IoT additive is typically the systems around machine condition monitoring. So pressure sensors, vibration sensors, temperature sensors associated with a piece of equipment, which might provide an early warning to a loss of production capability, is kind of the typical sensor applications I've seen there. What are the main challenges these sensors have in capturing the data? Well, I think it depends on which, if we're talking about the industrial sensors in those industries, one of the main challenges is getting working and consistently working sensors in place, but also the challenge is actually getting the information from the operating environment where lots of data is gathered, but also not passed on, and getting them into the cloud. And there are, as I said earlier, there are some solutions that are addressing the gap between the data that's gathered operationally and actually being able to make use of it on a business basis. Is there any particular space within industrial space that IoT is more used and starting to get benefits? This is Candy Bowles. Candy, I think really good question. I think the jury's still out, but one area that seems to be incredibly well suited to industrial IoT is the oil and gas industry, because they tick all the boxes on the criteria we talked about earlier. Massively distributed, huge pipelines, refineries full of miles, kilometres, hundreds of kilometres of pipeline and systems, and the need to be able to gather data. Any one of those sensors about that equipment might affect production, which is very expensive. So if you were to name an industry, I would probably say oil and gas. How should industrial IoT systems be designed? Dennis Sayer. Right, my comment would be, Dennis, incrementally. So start with the systems you've got, look at the capabilities, look at the sensors you need, and which additional sensors could provide benefit, and then actually don't look at an IoT solution until you know, from the point of view of your organisation, what's the most straightforward way to integrate that sensor. It may be just possible to integrate it through the existing programmable logic control network you've got in place, for example, or your energy. You may have an energy management system in place that will help you to use that. But it may also be beneficial to consider some form of IoT gateway added to your environment, which could perhaps just connect straight into your IT systems infrastructure. So, okay. What are some of the most effective mechanisms to understand the best industrial practices in IoT implementation? Really good question. I don't think I've got an exact answer to that. I've spent quite a bit of time talking to some of the systems providers in this space, and probably I would say the automation system providers rather than the bespoke IoT providers. A number of them have actually on their websites good case studies. They have to be broad. They can't give a lot of specifics away, but it will give you at least an idea. And I won't go through naming the automation service systems or service providers, but you can probably guess who they are. Okay, a couple more questions. What is the difference between industrial IoT and Industry 4.0? Okay, well that would be another seminar. And to my mind, in Industry 4.0, if I was going to sum it up in a nutshell, has three different dimensions. It's about addressing issues of real-time information and optimization in vertical integration of the business information system, in horizontal integration between organizations, and across the concept to product life value chain. And so, to my mind, industrial IoT has particular advantages in the second, and that is providing really effective real-time information integration across on a horizontal basis, so between organisations and their suppliers, customers, and other partners in their ecosystem. I think most people would say it's a contributor to Industry 4, not a separate, not an alternative. Although I know there's a lot of work going on to blur those definitions, so you need to look rather carefully. Which areas of industrial IoT require more research than others? That's an interesting question. I think, in a way, that last slide, which is still up there, maybe says that. And I'm not saying that the deal's done with items 1 and 2. In fact, actually, item 1 and 2 together are interesting, because quite often we get sensed information, object identity information, and we can't connect the two together. But I would say, on average, it's the area of taking information down back to objects and devices based on information that's been gathered is where we might want to focus our efforts. So around coming up with genuine ways in which objects and devices can communicate with each other, sort of a Babel fish, if you like, for object conversations, and how to most effectively and cheaply and logically support decisions that need to be made for an object, particularly when there's billions and billions of objects. We don't want to have them all having arguments with each other. So I think there's quite a lot of challenges there. Is real-time information also valuable? The answer is, I'm not sure quite where. This is Jung-Young, who's in Korea. Hi, Jung-Young. So real-time information is definitely valuable, and I think I would sort of split. There's real-time, time-critical, and non-real-time, and real-time is sort of dictated by a clock speed, and that can be important. I think most IoT applications today are not looking at real time, but some are time critical in that their data is being gathered in time to be able to make a decision which might influence the evolution of a set of operations. So I think real time information is valuable. There's probably less work in that space. Perhaps one more question. What is your view on the emerging commercial IoT operating systems from the big vendors? Right. Now I wish that was not a simple question to finish with, was it? So I mean, there are. I think perhaps the previous slide, second last slide, which said it's an immature space, sums it up. I think no one organisation has a comprehensive IoT offering for all aspects of IoT as we've discussed it today. I think the thing to be looking for, if you're trying to choose between them, is to what extent you own the data that's gathered in the systems, and secondly, to what extent the system is open and accessible for third-party users, because actually a lot of this is about permitted information sharing. And that would be the other comment to make is, those providers which provide a secure private access for data, it was certainly going to have an advantage in terms of the industrial space. So I think that's probably time to call it to a close. So just final comment is that, I know there have been quite a few other questions sent in, and thank you for all of them, and apologies for not answering all. What we would do is look at the other questions that come in and possibly broadcast on the website answers to some of the other questions that become available. And also just stay tuned for some further webinars and a workshop in this space into the new year. Great, enjoyed talking to you all. Goodbye.